Hello friends, welcome to my video tutorial under the data structures and algorithms. In this lecture video, we will be understanding what is the abstract data types in the data structure. So when you will going to study the data structure, you will come across the words abstract data types quite often. And with this theoretical concept, so we'll quickly understand this, and best way to understand is by taking example. So in this video tutorial, what exactly is abstracts or logical view and implementation view of the data structure. So that is the two way we can study the data structure, and we'll understand this by taking example. With that being said, let's get start. So what exactly an abstract data types? Now we have definitions of data structure which you already seen in the previous topic. We just review here. In computer science, a data structure is nothing but the way of data organization, management, and storage that enables efficient access and modification. And this is something we cleared out in the previous topics of this data structure. But the way we look data structure can be categorized in two parts or in two different types. The one is where we actually have logical, mathematical, or abstract view or model, where we just specify what are the things the data structure is going to have. So we have that data structure is the way of storing data, right? When I'm saying a way, it means that there are some protocols or there are some rules that must be followed. So all these protocols or all those rules can be modeled as a proper view or as a model, and it can be basically just write down all those specifications that comes under the logical, abstracts, or mathematical model or view. And the second way or the second part you can say is that the implementation part, where you use all those rules and regulations and actually implement that using some programming languages like C programming, Java, Python, PHP. So all these programming languages syntaxes will be based on the mathematical, abstracts, or logical view. So now you can overview of ways that you can look at the data structure. So let's start with, so all this programming syntax will be based on this mathematical, logical, or abstract model. So now that you have overview of ways which you can look at the data structure, so let's define what abstract data type is, and let's see example into consideration. Okay, so when you're talking about abstract data types, ADT is the short form. ADTs are the entities that are definitions of data and operations but do not have implementation details. So basically the abstract data type is the logical or mathematical or abstract view you can be talking about, right? So which means that we know we gone with storing, and we also know the operations that can be performed and the way in which data is going to be stored depending upon what data structures we are going through. But we are having it implemented it in any practical sense. The reason is why do not have any implementation in ADT is because every different programming language has different implementation. For example, a particular data structure in C can be implemented using the concept of structure, but that the same data structures can be implemented using the concept of objects and classes in Java programming, and so on so forth. Thus, different programming languages have different implementations, strategies to tackle different abstract data types. So basically, data structures are the abstract data types which has a specifications about how the data is going to be stored and what are the operations that can be performed on these data types, and these different entities, but the implementation depends upon the programming languages that we use. Okay, so to get these things more clear out, so let's take actual real world example. So here is a real world example of smartphone. If you look at these smartphones in the abstracts or logical view, so what are defining things that smartphone has at a high level? For example, the smartphone will have 128 GB RAM. Smartphone will have octa-core processor with 2.2 gigahertz. Then smartphone has a LCD screen. Again, it has a dual camera. It also have Android operating system. And along with all these properties, the smartphone also has some functionality, also has some operations. Stands for so along with these properties, with all this, the smartphone also has some functionality. The smartphone also have some operations and behaviors, right? So this is what the operation stands for, and this is the data, right? So information can be termed as data of that particular entity. So here we are looking at smartphone. So this is all the informations and data about that smartphone and operations. Or you can use smartphones to call. You can use the smartphone to view the video. Similarly, you can use this smartphone to perform some text operations. You can have operations for the photos and so on. So this come under the behavior and operations, right? So this is the what abstracts or logical view of the smartphone looks like, wherein we just stating all the different properties, all the different operations and behaviors that particular entity can do. But when we look at the implementation view here, so whatever the actually implementing this in terms of programming, in terms of actual codes, this is how the code will look like in the proper C programming language. You can see at the right side of the table. Here we have created structures with the tag name smartphone. We have different variables created here, like RAM size, camera count, screen size, then procedure names, then the version of the operating systems. So RAM size, procedure name, screen size, and the respective data types, obviously integer, then float, then characters. Okay, so then we have also some methods which we corresponds to these behaviors like call, video, text, phone. Obviously definitions can be defined later on, but right now I just want to state or show you how the implementation view would look like if you implement this in other languages like C++, Java, Python. Obviously the syntax is gonna changing, some keywords and some mechanisms is also gonna changing, right? That means the implementation view can change. However, the abstracts or logical view is independent of this implementation, so that is what abstract data types actually needs. Now coming to or the data structure word, let us take the example in the data structure environment. Okay, so let's take the basic integer array. So here integer array is declared as a size of 5. Okay, so we are having index position for this array is like 0 1 2 3 4. So array is a data structures where in that the collection of elements which are stored at the contiguous memory locations. So that's abstracts or logical view of this integer array can be stated as this data structures or this array stores a set of elements of the integers data types. So in this case we are using integer array, right? So you can also say of particular data type you want to go generic, read the positions by index. So we have index to access different positions starting from the 0. We can also modify the elements by index. You can also perform some sorting operations. Obviously there may be many more things that can be done using this array data structure, but right now I have just given an example of this, how the abstracts or logical view looks like. Now coming to implementation said, this is what looks like in the C programming. So the syntax would be, you can see in the table the right side in the second column, the array ARR is declared as a int. So here, so we are creating the array size. Okay, then the actual elements are given in this array from position 0. In the position 0 the element 10 is stored, in position 1 element 20 is stored, in position 2 element 30 is stored, and in position 4 element 40 is stored, and then 50 is stored, and so on. Then you can also see here the second statement scanf, where you are reading the or scanning the value or the elements at position 2. Then in the third statement CR of 3 equal to 100 means you are updating the element at position 3, which is already 40, which is replaced by 100. Then in the fourth row you are having the sorting operations or sorting methods, that is a sort and so on. So this is the basically implementation view. So when we talking about the abstract data types, it is just entity which have definitions or how is gonna stored and what kind of data is going to be stored and what are the operations that are going to operating on that particular data. So this was an example of array, right? If you go ahead and check out the other data structures like stacks, queues, linked list, graphs, trees, so all this, so we will move obviously see in the next video. So here this was all about the abstract data types. So I hope all of you understood this topic, and I conclude this topic here. So thanks for watching my video lectures. Thank you very much.